All right, so like I was talking about before, scale factor, which is again is something you might have put in your notes, is that ratio that we were trying for also tells us how much bigger or larger the shapes are compared to each other. Okay, so for example, and this will be a little hard to do because I don't have a stylus with me right now, but let's say this had a length of 3, AB, and DE, its matching side, had a length of 4. All right, well, what I would do is I would set up this ratio. And here's where you have to be a little bit careful. It's always the image. Let's say this was the original shape and it got blown up to this size. The new one goes first. So the length of 4 gets recorded first over the pre-image original, which was 3. So I get a ratio of 4 to 3, or 4/3, meaning that this shape, all the lengths are 4/3 times as big as this one. Or if it makes more sense to you to think of it as a mixed number, all the measurements on the second triangle are 1 1/3 times bigger than the ones on the original triangle. Alright, so let's take a look at our work for number 3. The following figures are similar. Fill in the lengths of the sides for the second figure if the scale factor is 3/4. Alright, so what we want to do is we basically want to take each side and figure out, well, how much did it shrink by? Because obviously by the picture we can tell this is reduction. I think the best way to start, let's call this side x. If I want to find x, what I want to do is I want to set up a ratio with x and its corresponding side. Now don't forget, it has to be the image over the pre-image, or the original, the new measurement over the original. So what I'll do is x over 2. Okay, that's important. A lot of ways people think about it, just the new one over the old one, new over old. All right, now our scale factor is 3/4. So what I can do is I can set up a proportion and say, well, whatever this ratio is, x needs to be a number that works out to 3/4. All right, so what I can do here is I can cross multiply. 2 times 3, which is 6. 4 times x, which is 4x. Then I solve this equation. Divide by 4, divide by 4. So x would equal 1.5 units, or in this case, feet. So over here, this is 1.5 feet. All right, and then I just go about it the same way for all the rest. Let's do these two sides because they're the same, 3 feet and 3 feet. So let's say this is y and also going to be y. All right, so first set up a ratio with these corresponding sides, new over old. So y over 3 equals my scale factor of 3 over 4. Cross multiply. 3 times 3, that's 9. 4 times y, that's 4y. Divide both sides by 4. And this would turn out to be 2 and a remainder of 1, so 2 1/4. So y on both of these, is 2, let's call it 2.25 feet, 2 1/4. All right, and then of course we do the same thing for the last one. Let's call this side z. So I would do z over 4 equals 3/4. Cross multiply. 12 equals 4z. Divide by 4. Z equals 3. So z is 3 feet. All right, so that's how you would use the idea of scale factor and similarity to find all the missing sides of our smaller reduction here. All right, let's take a look at number 4. Number 4, the following figures are similar. If A is 95 degrees, which I'm going to label right here, B is 85 degrees, C is 90 degrees, and D is 90 degrees, find the corresponding measurements over here. And so like we talked about, similarity between shapes is all about same shape, just not same size. So as far as the shape goes, these corners have to have the same shape, which means that the measurements have to be the same as well. So hopefully this was an easy one for you, because all you really needed to do was realize that all the angles should be the same, despite the fact that it's a smaller shape. That W was 95 degrees, X was 85 degrees, and Y and Z, these two corresponding ones, were both 90 and 90. So despite the fact that on number 3, the size of the sides changed, the size of the angles did not.